Okay, a nice simple question about reacting masses. In an exam, we've been given an equation which is already balanced for us. Calcium carbonate is heated, it thermally decomposes to calcium oxide and carbon dioxide. We have a known mass, which is 400 grams of calcium carbonate, and the question is asking us to tell us what mass of carbon dioxide will be produced. So, to start off with, we need to know the number of moles that we're dealing with. So the number of moles is equal to the mass divided by the relative formula mass. So for calcium carbonate, we've got 400 grams, and we need to divide it by the relative formula mass. So for calcium carbonate, calcium is 40, carbon is 12, and oxygen, we have 3 lots of 16, giving us a total of 100. So that means that we end up with 4 moles of calcium carbonate. Next, we need the ratio of the known to the unknown. So the ratio of calcium carbonate to carbon dioxide, which is what we're trying to find out, the number in front of the molecule or substance will tell you the part it is in the ratio. So here there's no number, so it's 1, 1, 1. So it's a very simple one, 1 to 1. So if we have 4 moles of this substance, we're going to make 4 moles of this substance. So the moles unknown is very simple, 4 moles of CO2. Now we need to convert that into the mass unknown, and the mass is equal to the number of moles times by the relative formula mass of the substance. So in this case, we have 4 moles of CO2, and the relative formula mass will work out just the same way. The relative atomic mass of carbon is 12, and the relative atomic mass of oxygen is 16, but there are 2 of them, so that's going to give us 44. So if we multiply those together, it gives us 176 grams of CO2. And there's your answer. We can take it one stage further just to prove the conservation of mass. If we started off with 400 grams of CaCO3, calcium carbonate, we're going to make 176 grams of carbon dioxide. We must therefore make 224 grams of calcium oxide, as the mass in is always equal to the mass out. Okay, another question now, only slightly more tricky, but we'll do this one in the same format. I'm keeping these exactly the same, just so you know the process that we have to work through. So in this one, we have a reversible reaction making ammonia. And in the question, they ask, what mass of nitrogen would be required if the reaction went to completion to make 4 grams of ammonia? So exactly the same process. This time, we're going to check that the equation is balanced, and obviously we can see that it isn't. We will need to double up the number of nitrogens in ammonia. So the number of nitrogens, 2 there, 2 here, but now we have 6 lots of hydrogen, so we now need to put a 3 in front of this hydrogen, and that's really important when we come to our ratio section. So we've got 4 grams. Now we need to convert that into moles, and the number of moles is equal to mass divided by relative formula mass. So here it's 4 grams divided by, and nitrogen is 14, and hydrogen is 3 lots of 1. The 3 comes from the fact there are 3 hydrogens there. So that gives us a total of 17. Do not use this number 2 to double it up at this point. That's just confusing. This number in the front of the molecule only appears when we do the ratio. So the relative formula mass is 17, which gives us an answer of 0.235 moles. As a good tip, always leave the full number in your calculator, and then it'll carry on the full number of decimal places in the calculation. but always write the answer as you go along, because if you make a mistake, then an examiner will give you marks for how far you've got through it. Then the ratio is the next section, and the ratio of ammonia to nitrogen is the number in front of the molecule. Now this time, in front of ammonia there are 2, and in front of nitrogen there's nothing, so we put that as a 1, which means that for every single ammonia there are half as many nitrogens. So that means that the moles unknown, so the moles of nitrogen, is equal to 0.235 divided by 2. There are half as many. So that gives us 0.118 moles. And as you can see from that, it doesn't quite add up, and that's because I've kept the full digit in my calculator when I've worked that out. Now we're going to convert those moles into mass. So the mass of nitrogen needed is equal to the number of moles multiplied by the relative formula mass. I'm not using atomic mass because this is a molecule and there are 2 of them. So the moles we're keeping as 0.118, but I'll actually use the number in my calculator. And the relative formula mass, there are 2 lots of 14. So it's 2 times 14. So the relative formula mass is 28. And that gives us a mass of 3.29 grams. And although that looks quite high, if you think about it, 3.29 grams of this 4 grams comes from the nitrogen, only a tiny bit comes from the hydrogen, but hydrogen weighs much less.